Hello everyone. I will now present to you the answers of our problems yesterday or from other classes last Monday. So here in our example number 1, we are given the equation 9x squared minus 16y squared is equal to 144. And then we're asked the following questions or properties of the hyperbola. So we have to write our equation into standard form. And to do that, just remember that the right side must be a 1. Okay? So perhaps we can start there. So we divide both sides with by itself. 144, and whatever you do on the right, do on the left. So now, 144 divided by 144 is 1. And in here, we can actually rewrite 144 as 9 times 16. And we can cancel out the 9. So what will be left is x squared over 16. And here, similar process, 144 can be written as 9 times 16 because that's the factor of 144. And now we can cancel out the commonality in the numerator and denominator, which is 16. So you have y squared over 9. Now looking at our equation, this is already the final equation in standard form because the operation in the middle must be a minus. Okay, and by looking at this one, x squared comes first, right? The ones on the left, the minus. So automatically, if that happens, it's horizontal. Now, how about the center? Okay, that by simply looking at the numerator, the ones being raised to a power of 2, it's just the x. Same here with the y. So automatically, if that happens, the center is at the origin with the coordinate 0, 0. So you can look at your summary formula now so that you can figure out what is being asked. So your focus is here, horizontal hyperbola with center at the origin 0, 0. So we can start with the focus based from the summary. It's either a positive or negative of the A, but the problem is we don't have the A yet. Okay, so that's our next concern. Okay, so if you try to look in advance, for vertices we need the A, for our foci we need our C, and later part you will also realize that in asymptotes you will also notice that there's a B. So we have to figure out first what's the A, the B, and the C. Okay, now since we know that it's in horizontal, it's a horizontal hyperbola, and we follow this form. Again, it's from here. We can conclude now that 16 is equal to our a squared. So we just have to get the square root of both sides. You'll get 4. And then next, b squared is below the y squared, and that's a 9. So b squared is equal to 9. The square root of both sides would be b is equal to 3. So you have your a and the b already. So now what's missing is the c. But we know that the relationship of our a, b, and c is c squared is equal to a squared plus b squared, where the a is 4 and the b is 3. That would be 16 and 9, and 16 plus 9 is 25. So get the square root of both sides, so c is 5. So we have our a, b, and c already, and this is the best time for us to figure out what is being asked again. So we'll start from foci. Foci is the positive or negative of the c. So positive or negative for a while. Okay, here, positive or negative of the c, and the c is a 5, then 0. Next would be the vertices. Okay, the vertices is just the positive or the negative of the a, then 0. Then now, the length of transverse axis. So if you remember from our synchronous, it's just the length from one vertex to another. So therefore, that's just 2a. So 2 times a is 4 is 8. So the length of transverse axis is 8. Then next, we're asked to figure out the asymptotes as well. So the asymptotes, it's just x is equal to, not x, that's the directrix. I mean, asymptotes is y is equal to the positive or negative of b over a, where b is 3 and the a is 4, then x. So this is now our final answer. Okay, let's now continue in our example 2. So we're still given with the equation, and we're asked as well about the properties of our hyperbola. So whether you are told that it's vertical or horizontal, you will figure it out later. Okay, so for now, there's already a label, so you know that it's vertical. But let's assume that we don't know that it's vertical. So first of all, we have to make sure that our equation x squared minus 9y squared plus 9 is equal to 0 is written in standard form. And for now, we have two problems unlike example 1. The right side is a 0 and not a 1. And on the left side, there is a term which is just a constant. So what you need to do, we have to get rid of the 9 first by adding its additive inverse or its opposite, negative 9. And then this will become 0. So what will be left is x squared minus 9y squared. And on the right, 0 plus negative 9 is negative 9. Okay, so similar to our example 1 already, we make sure that the right side is a 1. And that will be possible by dividing both sides by negative 9. So this will become 1. X squared over negative 9 is just, that's just it. But instead of putting the negative in the denominator, we can put it here in the middle. And this is a minus 9y squared over negative 9, but we can think of this minus as a sign of the 9. So negative 9 divided by negative 9 is a positive. So that means plus y squared over 9. Now, in our standard forms, what is in the middle will always be the minus. And for now, it's a plus. That means we need to switch both terms to follow the standard form. So that will become y squared over 9, then minus x squared over 9. Oh wait, this is a 1 because the 9 is cancelled out. So it's okay not to write a 1 anymore. You can just think of it as y squared. So, similar with our example 1, we need to make sure that we'll be able to figure out the A, B, and C, as well as the decision whether it's horizontal, vertical, or if the center is at the origin or not. So by simply looking at it, we know that the origin is our center. It's because what is being raised to a power of 2 is just the y and the x, and nothing else. So automatically the center is at the 0, 0. Now, as I said a while ago, whether you were told that it's vertical or not, you will know. It's because um, based from the order of our equation right now, what comes first is the variable y. That means if it's variable y, that means it's vertical. But if x comes first, following the format of the standard form for hyperbola, then that's the time that it becomes a horizontal hyperbola. So let's continue. So we know that we're looking at our vertical, okay, vertical hyperbola. And what's the denominator of y squared? That's our a squared. Okay, look at here. The denominator of y squared is 1. And the square root of both sides is just a is equal to 1. Next, the b is below x squared. So b squared is equal to 9. So get the square root of both sides, you'll get 3. Then now, for the c, use the relationship between the three of them. So c squared is equal to a squared plus b squared, where a squared is 1, b squared is, okay, that's just a 1, so we all know that. 3 is 3 squared, so 9, and then 9 plus 1 is equal to 10. And then you need to get the square root. So that would be square root of 10. Okay, so you have your A, B, and C now. You can already figure out what is asked from you. First, with the vertex. The vertex is again, or the vertices, rather, is just 0 for x coordinate. Positive or negative of the A, which is 1. Next would be the foci. Foci is here. The x coordinate is 0. Then the y coordinate is either positive or negative of the C. Then next, we're asked about the length of the transverse axis. The length of the transverse axis is again just it's just 2 times a. So 2 times 1 is just 2. And then next, the asymptotes. Okay, the equation of our asymptotes is just y is equal to positive or negative a over b. A is 1, b is 3, then x. And that's our answer. Okay, let's now continue with example 3. We're asked to find the equation of the hyperbola with the vertices positive or negative 3 and 0, and foci, which is positive or negative 4 and 0. So, you have to figure out the center, the A, and the B. By simply looking at example 3, oops, um, as I said during our synchronous, by simply looking at The y coordinate now, they're both 0. So automatically, your conclusion here is is that the center is at the origin. And then you'll notice that there are changes in our x coordinates for the vertices and the foci as well. So in other words, that's horizontal. So you will just look at the summary formulas for horizontal hyperbola with center at the origin or 0, 0. So provided that we have the vertices here, vertices involves the A. Okay? So that's positive or negative 3, 0. And again, this is our A. So therefore, we can conclude already that A is equal to 3. Then next for the foci, oops, the foci now is positive or negative 4. And based from our summary of formulas, that would just be positive or negative C. So therefore, we can conclude that C is equal to 4. We still need to find the B. So we use the relation now. So that would be B squared is equal to C squared minus A squared, where C is 4, A is 3, so that's a 16. This is a 9, and then 16 minus 9 is a 7. And then get the square root of both sides, you'll have square root of 7 as your B. So you have your A, B, and C already. You can already come up with the equation of the hyperbola. And remember, this is horizontal hyperbola with center at 0, 0. So here. So you just have to substitute. So that would be x squared over the A here is 3. So 9. Then y squared minus b squared. By the way, when you get again the square root and the square root of 7, that is just 7. Okay? So 7. And this is now our final answer. Okay, now let's continue with example 4. So in our example number 4, you're now given with the foci and the asymptotes. So how will you get the answer for that? Okay, similar process. You will notice that first of all, your x coordinate for the vertex is 0, but the y coordinate changes. So with the 0 and 0 as your x coordinate for the vertices, the center would automatically be at the origin. And then the y coordinate changes, so that means it's vertical. Okay, so now we're looking for the equation. We still need the A, the B, and the center, but we know the center already, and it's 0, 0. So we can focus our attention here. So vertical hyperbola with center at the origin or 0, 0. So looking at our summary formulas here, the vertex involves the A. That means that we can easily conclude that our A here is a 2. Next, um, we're also given with the asymptotes. The asymptotes, that's y is equal to positive or negative 2x. And as you can see here, for vertical hyperbola, you have y is equal to positive or negative a over b x. But our a over b here is just a 2. So you can just write it as a over b is equal to 2, and we know already what's a. That's a 2. So we can now cross multiply. B times 2 is 2b. Then the denominator of this 2 here is just 1. So 2 times 1, 2. So b is equal to 1. So we already have the a and the b. Then we can already write our equation, which is y squared minus x squared, but the denominator would be a squared. So that's a 4. Denominator of the x squared is the b squared. That is just 1, is equal to 1. You can write it as y squared over 4 minus x squared is equal to 1. Okay, let's now continue with example 5. So in our example 5, we're given with the equation of the hyperbola x squared over 9 minus y squared over 4 is equal to 1. And we're asked to figure out the foci and the vertices. So first of all, you would know that this hyperbola has its center at the origin. It's because looking at our equation, what is being raised to a power of 2 is just the x, and here just the y. So the center is at the origin. Now, to decide whether it is vertical or horizontal, by looking at the order, the first the first one is with the x. So that means it's horizontal. Now, the horizontal hyperbola with the center at the origin has a standard form, which is x squared over a squared minus y squared over b squared is equal to 1. So take note, finding the foci and the vertices, it involves the c and the a. So that's what you need to figure out. So probably you'll look for the a, b, and c if that's its situation. So for the a squared, that's a 9. So that's a 3. And then for b squared, that's a 4. So b squared is equal to 4. And the square root of both sides is b is equal to 2. Now, your concern would be the c. Use the relationship between a, b, and c. C squared is just equal to a squared plus b squared. So that would be 3 squared. And this would be 2 squared. So 9 plus 4 is 13. And you need to get the square root of both sides, the square root of 13. Now you can figure out already the foci. The foci is actually is just the positive or negative of the c and 0. And then for the vertices is just the positive or negative of the a, which is 3 and 0. So there you have it. Okay, let's continue to example 6. We are asked to find the equation of the hyperbola whose vertices are located at 0, -4, and 0 and 4. And these foci are located at 0 and -5, and the second foci is at 0 and 5. So perhaps we can just write it as vertices at 0, positive or negative 4, and then the foci 0, positive or negative 5. And by looking at it, the x-coordinate is a 0, so you can think right away that the center is at the origin. And the y coordinates changes or vary, so that means it's vertical. Okay, now for you to figure out the equation of this hyperbola, you will need to find the a and the b. And the center, you don't have to. So now, given the vertices, for vertical hyperbola, the vertices would just be 0, positive or negative of a. So therefore, we can conclude that our a is automatically a 4. And for the other one, the foci, it is now 0, positive or negative c. So therefore, the c is a 5. And use the relationship between the three variables, that would just be b squared is equal to c squared minus a squared, where c is 5, a is 4, and that would be 25 minus 16. 25 minus 16 is a 9. So get the square root of both sides, you'll get 3. So there you go. You just have to use the standard form for vertical hyperbola with center at the origin 0, 0. Then substitute. A is 4 and 4 squared is 16. B is 3, so b squared is a 9. So this is now our final answer. Let us now answer example 7. Our task is to rewrite this general form to standard form. So bear in mind that you will easily remember that it's already in standard form if the ones on the right is 1 and what's on the left, there's no term which is constant and it's being factored out using difference of two squares. Okay? So if you have 9x squared minus 16y squared minus 18x plus 32y minus 151 is equal to 0, first thing, you have to get rid of this part because it's just a constant, no variable with it. So in your mind, you have to add a 151 on the left to make it 0, and you do the same thing on the right. So you will have 9x squared minus 16y squared minus 18x plus 32y is equal to 151. Then next, do not mind the 151 yet. You have to factor this first. Okay? So your ultimate goal is to factor them using difference of two squares. And there are two variables involved, so you need to group together those terms with the same variable. And enclose them in parentheses, by the way. So that would be 9x squared minus 18x plus you have negative 16y squared and then 32y. So next, if you notice, if we wanted to factor this using dots, there must be three terms. But the problem is for each group, there's only two. So that will give you a hint that you're about to use completing the square for it to be factorable using dots. Okay, now to do that, we make sure that the leading coefficients would be a 1. That's why we need to factor out the 9 from here. And what will be left is just x squared from 18 if we get the factor 9 from it. So that would just be 2x. And then in here, that's a negative 16. So if we have to factor that out, so that what will be left is just be y squared. And from 32, since it's a negative 16, it must be negative 2y. Why not plus? Because negative 16 times positive 2 will make it negative. And take note, originally it's positive 32y. So we have to be careful about the sign. Now, the process of completing the square, you have to take away or use the value of b, the ones beside our variable, the variable with an exponent 1. So, you have negative 2 in here, divide it by 2, then raise it to the power of 2. So, negative 2 divided by 2 is negative 1, and then squared, just a 1. So, you need to add a 1 in here, but whatever you do on the left, do on the right. You're adding a 1, but take note, outside our group, there's a 9 outside it. So, it must be 9 times 1. Next, in here, the b is also negative 2. So, they will end up with the same result, which is 1. So, you have to add a 1 in here, but whatever you do on the left, do on the right. So, this would become 1, but outside the 1, again, this is not just a 16, but a minus 16. So, you'll do the same thing on the right. And there you go. It's already factorable by dots for difference of two squares. So you just have to include, the result will just be a binomial. Square root of x squared is x, square root of 1 is a 1. The operation in the middle term is a minus. And then here, still, the square of a binomial, square root of y squared is y, square root of 1 is a 1, middle is a minus. So here, if you use a calculator, 151 plus 9 minus 16, you'll get 144. And now, this is the best time for you to do your thing with the 144. All we need to do is divide both sides by 144. Whatever you do on the right, do on the left. So 144 divided by 144 is 1. But take note, 144, we can factor out 144 as 16 times 9. So instead of 144, 16 times 9. Then we cancel out the common, which is 16. Same here in our 144 in here. We can write it as 16 times 9. And you can cancel out the 9. So the result would be the square of x minus 1 over 16. And then the square of y minus 1 all over 9. So this is now our answer. So if we just want to continue this, we can already identify the property. So first of all, it's in the form already. Beside x and y, there is a number with it. Okay, that is being raised to a power of 2. That means the center is not anymore at the origin, but instead it's at h and k. So yung nauna is horizontal, Yung nauna is x, so therefore we can conclude that it's horizontal. And then yung h natin is 1. So if it's a x minus 1, that is just a 1. Then take note, this is y minus k, so the k is just 1 as well. And then yung a natin is the square root of 16, 4. B naman natin, square root of 9, so 3. Okay, our last problem is about nautical navigation using LORAN. So I hope you were able to search on your own what's a LORAN. So the meaning of LORAN again is long range navigation. Okay, so actually there's a missing information in example 8. So I would like to use this opportunity to add what's missing. So in example 8, supposedly there's an information as well that the speed of the ship is, or we can think of it as velocity. Because I think from what we have discussed in the class, we're using the word velocity. So it is 186,000 miles per second. Yes. Okay, so actually the problem that we encountered last time is similar to what we have right now. So think of it as if you are making you're trying to plot them in a coordinate plane. So it says in the problem that there are two Lorans, which is 200 miles apart. So consider the following Lorans as your foci. So it can be here and here. And the center, we will assume that it's at the origin to make it easier. Since they're 200 miles apart, so perhaps from center going to our first foci, that would be 100 miles. So 100, 0. And then in our, okay, wait, let's consider this as our second station. And this is our first Lawrence station, which is also 100 miles away from the center. So negative 100, 0. So from center, going to our, from center going here, in our, either of our two foci, that would give us the length of the C. And the C is 100. Okay, now, take note that the two stations is here in the shore. So try to imagine that there's a shore in here. And the Lauren is here. And this is the sea. So actually the path followed by a ship would be hyperbolic. So let's say it's here in our quadrant 1. Okay, from here. So try to imagine that there is a hyperbolic curve followed by the ship. So the location of our ship would be either of the two, but based from the problem that they have time difference. So let's assume that it would be the first station who with a delay of 0.00043 seconds. So our goal here is to identify where will the where will the where will this where will this ship will land in the shore. So here. Okay? So that's our concern. So similar from yesterday, always remember that this is the constant, the concept behind hyperbola. The distance from one focus to going to the location of one of the ship, or one of the points in our hyperbola, from here to here, and from here to here as well. Okay. So take note that um, there is a positive constant that you can come up when you try to find the difference of the two distances. And that is represented by 2a. And that 2a is equal to the distance that we will um, the distance that we will be able to get from the given time and velocity. So we'll figure out first the distance, okay, from the ship going to, let's say, the first station. So use the formula. Velocity is equal to distance over time. We know that the velocity from this is 186,000, and then distance is unknown, and then the time is 0.00043. So you just have to cross multiply, so you will get 186,000 in our calculator oops, times 0.0043. So you will get 79.98, but it's okay to round off. So approximately that would be an 80. Okay, let's be exact instead so that we'll be sure with our values. So let's say 79.98. So if the distance is 79.98, we just have to substitute it here. So take note that it's just equal to 2a. So divide both sides by 2. 79.98 divided by 2. So you will get 39.99. So that means that um, the location, the specific location of our ship in which it will land in the shore, that would be our vertex. Okay, that's our vertex. So and our vertex again involves A. So the location from here, since it's positive, so that would be 39.990. Or approximately, we can consider it as 40 already. So that means our conclusion in here, the ship reaches shore between the two stations. One is 60 miles from station B. Okay, why is it that it's 60 miles? Because looking at this is 40, right? From here, our second station, this is 100, and this is 40. So 100 minus 40, you'll get 60. So from here to here, that's 60 miles. And then, how about for our station A? Our station A, that would be 40 miles. That's 140 because from here to here, from center going to our first station is actually 100, and then from here to here, that's 40. So 100 plus 40, 140 miles. So this is now our answer.